So, if you look at India, per capita energy consumption is very low, but in terms of total energy consumption and GHG emission, we are now third and going up, we will become number 2 in time to come. As our GDP goes up, our energy usage and GHG emission increasing. We have also seen renewable energy cost very little in India, but renewable energy will require storage. Storage cost is extremely high, and we will talk about it. So, if I have to have storage along with renewable energy, the cost goes up. So, to the extent that I can vary the coal plant up and down and gas plant, I can use some amount of renewable energy. Currently, I am using 8%, probably 20% I can go, because variation in other things are possible. But as I go above that, I will be in trouble. But then I have to control renewable energy. And what do you do? This is what I am going to present, a new approach that we have come up and are implementing in IIT Madras Research Park. Basically, fundamentally what you have to do, or you have all this AC grid in the country, from renewable energy or from fossil fuel. This is the AC. You convert, do AC to DC converter, bidirectional, you will convert this side as well as this direction, and then you have to have energy storage available in demand. Whenever there is surplus, dump the electricity there, whenever there is deficit, bring it out. I will initially talk in context of a battery, and particularly on lithium ion battery. So, how much does this storage cost? How do I take the storage cost into account? Ideally, what I would like to, so there when I buy battery, when I make battery or buy battery, it is very expensive. There is a large capital cost. But how does it add to my per kilowatt hour cost of electricity? We will compute that. But first, the capital cost. How much does it cost? 20,000 rupees per kilowatt hour, 15,000, 30,000 per kilowatt hour, and I may buy 100 kilowatt hour or 1,000 kilowatt hour, a megawatt hour or 10 megawatt hour. Tomorrow I may buy 100 megawatt hour or gigawatt hour, because I am consuming electricities in terms of gigawatt hours. So, multiple gigawatt hour, that I have to have a capital cost. Batteries are expensive. Then when you buy battery, you charge, discharge, you keep charging, discharging. Every time you charge and discharge the battery, battery life goes down a bit. What do we mean by battery life? Battery cannot be charged, discharged forever. Its capacity goes down slightly. So, you can do only so many number of charge discharge cycles. I have taught you in electric vehicles part of it. So, what is the number of charge discharge cycles? Then what is the operation cost? If I charge once and discharge once, what is the cost? Fortunately, not that much. How many cycles will I use per day? Will I charge in the morning, then use it in the afternoon, then again charge in the evening, and then use it in the night, or what do I do? Do I do it twice a day, once a day, 1.5 times a day, 3 times a day? You will say, wow, how does it matter? You will see it matters. Of course, I have a total number of cycles, I can do so many. If I do 3 times a day, it will last less. Then I have to replace it. But you will see that if I can use 3 times a day, it is better, because you will see the computation, whether if I use it only 1 time a day or half a time a day, it is not as good. So, how many cycles will depend on when is renewable energy available and when is usage available. If I am using solar and wind both, maybe solar is peaking at some hours, that is the time I will charge, then solar is going down, that time I may discharge, then wind is peaking some other time, I may charge, and then that is also going down. So, in fact 1.5 times if solar and wind is there is quite easy, but 2 or 3 times a day if I can do it, my cost goes low. Then if I store it, does the energy decay? Fortunately, the kind of batteries that we are talking about does not decay very fast. Lithium ion practically no decay in a day, 2 days, 5, 4. But if you keep it for 1 month, you store it and keep it, then the issue is different. End-to-end energy efficiency. What you have to do? You have to take AC energy, convert it to DC. You have to charge, store, take out the energy, convert it back the DC energy into AC. What is the end-to-end loss? And typically for large battery you can get 95%, 96%, 97%. So, there is a 4-5% loss for lithium ion battery. That is kind of best that you can do. Probably 97%, tomorrow it may become 98%, but that is, you will get some losses there. Using all this, you have to compute what is per cycle charge and discharge, and that I have to add to my renewable energy cost. Per kilowatt hour, how much is the generation cost, how much is the storage cost, so that I can get it whenever I want. We will do this exercise. What does it depend on? If you look at it, there are 2 kinds of cost. In pretty much anything there are always 2 kinds of cost. One is capital cost, one time cost. Of course, for overall there is a lifetime of number of cycles, and number of cycles used per day will give you the lifetime. So, capital cost and lifetime and operational cost. I have to take both into account. Operational cost can be easily calculated per kilowatt hour. If I am spending 50 rupees per day and I am generating 500 units, it is 10 paise per unit. Capital cost, how do you take into account? After some time, that capital initial whatever you have put in will become nearly 0. So, the terminology used for this, I taught you in electric vehicle course, is also what is called depreciation. You will depreciate the value, initial value of the battery over its lifetime. Its cost will keep coming down, finally it becomes 0, then you are taking it out. And since you have put in a capital cost, you have to borrow money, you have to take the interest cost also into account. Interest cost plays a very important role, we saw that in this. So, for the capital expenditure, we will take depreciation interest. For the operational expenditure, we will take the actual operational expenditure, we will take all the losses, and we can calculate cost per kilowatt hour. There is yet another cost very often ignored. What is the environmental impact? Now, I am trying to see that my greenhouse emission does not take place and environment does not get impacted. But on the other hand, can this battery toxicity, hazards, recyclability, they have important role. Very often this is ignored. We are trying to include that and say we want to make sure that the battery that we use does not have environmental impact. Otherwise, you have to take the cost. So, let us do an exercise here. You know, you are generating renewable energy from the grid. It is not that all the renewable energy generated has to be stored, because much of the renewable energy whenever it is generated can be used. Some amount you have to store to use it when there is no renewable energy. When renewable energy is available, you will directly use it. You will not go through the storage. When renewable energy is not there, for that you have to store. Let us assume, and we will play with this number, 70% is used directly and 30% through storage. Now, you may ask why 70%? We change these numbers. Actually, 70% is fairly good number, particularly if you have a solar and wind plant, more than 70%. 70% can be used more or less instantly. Some 30% goes into this. We will talk more about it. So, let us assume that S is the store cost of the battery per kilowatt hour, charging and discharging. So, and generation cost is 2 rupee 50. So, S 2 rupee 50 paise plus S is the cost when you put it through storage. When you do not put it through storage, cost is only 2 rupee 50 paise. The question is, and this is done for 30% electricity, how much is S in India? We will compute this cost. But what we have done, 70% is used directly 2 rupee 50 paise, 30% of the electricity is used 2 rupee 50 plus S, which if you convert it is 2 rupee 50 plus 0.3 into S. So, as long as you know the storage cost per kilowatt hour, you just need to do 0.3 times and add it to 2 rupee 50 paise. If I was using 50% electricity through storage, this 0.3 number will become 0.5. Very simple, school mathematics, nothing more than that. Now, let us take the batteries. What we did is that I took the batteries which are today available in my lab. I took two batteries, well, one of them I know it is not much available. This is a LTO battery, expensive, but it can give you large number of cycles, 15,000. The others is a high end advanced NMC. I have some low end NMC also, I have kind of ignored them because they are not the best for long term storage. But this cell A is around 20,000 rupees. 20,000 rupees is not the cost of cell, it is the cost of the full battery and the converter. I have taken all that cost. 20,000 rupees per kilowatt hour, I can do about 7,000 cycles before I have to renew the battery. So, the cost here includes the grid connect cost, the converters and things like that. So, my total cost, if I want to build a megawatt hour battery, is 20,000 into 1000. That is what I have assumed. 20,000 into 1000 will become 2 crores. That is the cost per megawatt hour, including converter. Okay. Now, I have taken interest rate. Now, interest rate in Europe, United States is 2%. In India, interest rate is high, 10%, probably even more 11, 12, 13%. So, what I did is that I varied the interest rate from 2 to 10%, I can actually do it even higher. And then took the capital cost which I have just given and all the operational cost, took the losses into account and calculated this. If we assume that I use it only once a day, every day I charge once and discharge one, that is the data. And these are the costs. If I look at it at 2% interest, the cost is about 3 to 4 rupees per kilowatt hour for both the batteries. In fact, it does not matter whether I use one battery or the other. But if I take 10% interest, this 350 or 4 rupees becomes 7 rupees for advanced NMC battery. For LTO battery, it goes up to 11 rupees. LTO battery is lasting longer. Why is it costing more? Because the initial amount that I pay is so high that its depreciation becomes higher. Now, this is a very simple exercise and I have done that in the past, but I want to once again warn. There are plants being set up by government, pushed it, and private sector also. They are advised by the Europe and United States. They come and tell, put LTO battery. In their country, it is better, probably equal. They have not even understood the Indian interest rate is 10% or higher, 12% will go up even higher. And they were advised, and government of India sanctions the money. People sitting there, all the big people, they do not even do simple calculation. Why? Their advisors come and give them, and that is it. But if we have to do it ourselves at our own cost and what makes economic sense, then learn after some time. Advanced and MC will become the better choice for now. Tomorrow it may change. If I do 2 cycles per day, if I am able to do 2 cycles per day and I have solar and wind together, then I may be able to do close to 2 cycles. I may not do 2 every day. I may do some day 1 cycle, some day 2 cycle. Average may be 1.8, 1.7 cycle per day. But if I do 2 cycle per day, slope decreases. See, it no longer goes from 350 to 7 rupees. It goes up only from 3 rupees to 5 rupees. Under 5 rupees, 4 rupees 75 paise. This also slope decreases, but this also does not go to 12 rupees, it goes to more like 7 rupees. But certainly the NMC cell is much better, it goes up to 4 rupees 75 paise. So, 2 cycles per day will be much better, but that is not in my control, it depends on when I need it and all that. So, the actual number will lie somewhere in between. So, my actual cost will be between 4 rupees 75 to 675 per kilowatt hour in India. I have to assume 10%. So, that is what I am saying, between 4 rupees 75 and 7 rupees per day. In West it is less, and you can choose either. If I now take 70% is used directly and 30% through storage, and I put 2.50 rupee 50 plus 0.3 into S. S is now between 7 rupees to 475, and my total cost will work out to be 3 rupee 95 to 460. So, it would have been more like 2 rupee 50 paise, but because 30% goes through storage, I am adding a rupee 50 on the lower side, maybe 2 rupees on the higher side. This is today's cost. Remember, 4 rupees, 3 rupee 95 paise is very good cost. How much do we pay for electricity today? Home users typically pay around 6 rupees, including taxes. Industry user pay more like 8 or 9 rupees. The research park, IIT Madras Research Park, which is classified as a commercial entity, some kind of commercial entity, we pay closer to 10 rupees. All kinds of charges are there. So, we pay much more. Plus, if there is no electricity, I have to use diesel generator. And if I take that into account, no electricity is not there for long nowadays, power cuts are very less, but that will add another rupee average cost a rupee. So, my cost is 11 rupees per kilowatt hour, that is what your research park pays. Here my cost will only be 4 rupees including the storage. Of course, this is at the generation point, now I have to add transmission and distribution, all those costs I have to add. This is the base cost. If you look at, it is still very good compared to coal. So, even with storage it is not that bad, and remember the storage cost will go down further going forward. Okay. So, this is something that I wanted to. Then this course is being taught by me and Dr. Kaushal Jha and Kannan together. Dr. Kaushal Jha is working with us to do another storage. This is not lithium ion battery storage. This is what is called thermal storage. Actually, it was conceptualized by me about 6-7 years back, and we have built this. It is going to be operational now. You know, much of our load in a building like research park is air conditioning, almost 40%, a little less, 35 to 40%. What do? I have a chillers in my basement which chill the water to 6 degrees centigrade and circulates it all over the building. So, that every building uses that to cool their water, cool their air and blow the air inside the room. That is the reason you are sitting comfortably at 25 degrees centigrade. The chilled water that comes to your room starts at 6, may go up to 7 degrees centigrade. Whenever I have excess electricity, so my main electricity consumption is in chiller, chilling the water. What if I take, whenever I have surplus electricity, I chill the water to 6 degrees. Whatever excess electricity, I chill even more water and store it in a thermal storage, insulated thermal tanks, nothing more than that. If I can insulate my thermal tanks, I can just push the water there, and then when I have deficit of electricity, I will take that water and circulate it. I do not have to use the electricity at that time. So, essentially it is acting like a storage. Whenever there is excess electricity, I am storing the energy, of course in form of chilled water, and whenever there is a deficit of energy, I do not chill water, any fresh chilled water, I actually use the chilled water to cool the building. This, all that we need is a thermal storage. Of course, will the temperature keep going up? Slightly. If I keep it at 6 degree centigrade, depending on the thermal insulation, it may go up by 0.5 degree. Today it is going up by 0.5 degree per hour. So, if I keep it for 6 hours, it goes up by 3 degrees, which is not as great, but it is okay, not that bad. But if I put more thermal storage, I probably can, it will go up by only 0.25 degrees per hour. So, even in 3 hours, I mean hardly add 1 degree. Then I can chill a little bit of water and mix it, there is no problem. We will assume average loss is about 5%, and this is what we could do. We have actually built a capacity of 2.5 megawatt hour and we are just starting to use it. This cost is much less than lithium ion cost. Why? Because I am not putting these expensive batteries. What is the primary cost out here? Well, I already have the chiller. I am just using the chiller when there is excess electricity. I always have enough chillers. Storage cost is a one time cost, thermal storage will not cost much. I have to put some extra pumps and valves and measurement devices, that is also one time cost. So, not that significant. We will do a detailed cost, Kaushal and Anson will do that, but including all costs, overheads, operational cost, there will be a little bit of operational cost, not very significant. Remember, however, I can use this storage only for air conditioning, I cannot convert it back to electricity. But the two can work together, lithium ion storage and chilled water storage. And frankly speaking, I can increase chilled water storage, building more thermal tanks. That is one area of research we should start doing. How do I build good thermal tanks?